So the 4, 5, and 6 objectives explain why the regression line is called the least squares regression line. Explain how the coefficients of the equation y hat, and did not misspell or mispronounce anything. This is y hat equals a plus bx can be found given your correlation, standard deviation of just your x variables, standard deviation of just your y variables, and then the averages of your x and y variables. And then given a bivariate data set, use technology to construct a least squares regression line. These three objectives are supported by pages 205 to 214 in your textbook. Least squares regression line is a line of y on x, is a line that makes the sum of the squared vertical distances of the data from the line as small as possible. So what does that mean? Well, here's one particular picture. It uses your observed and your actual. So here, we're predicting a value of 3.7, but we really have a value of 3. It gives us an error of negative 0.07. So in other words, we overestimated this particular value. Well, what does that tell us? Well, as we look at a least squares regression line, we have our regression or our predicted values as we look at all of these. So like this is our predicted value. Here's our actual value. Well, if we were to find that difference and square them, we would get several numbers that we could add together. Well, when it says least squares regression line, so we've got, say, a bunch of data, and we're only going to look at the red data. I need these black points as we go through. So let's say we calculate our least squares regression line, which is what I've got right here. Again, we're looking at our red points. And then we take our actual minus our predicted, and we find the distances and make squares out of all of them. Now, what we can do next is use technology and find the sum of all these squares, the areas of these squares. Now, as I move this line around, the sum can vary. So this line might be the line we use to predict, but that area is 21.05. I could use the line to predict, but it's 28.27. So the idea is that we move this line so that it gets to the smallest number possible. So we got 12.15, 11.87, so about 11.8. So this is where our least squares regression line would fall. And actually, yeah, 11.79, 11.8. So when we discuss least squares regression line, that's what it means. That's just a quick picture example. So here's the equation of the least squares regression line. Again, y hat stands for our predicted a plus bx, not mx plus b. Slope, our b, is calculated by our correlation coefficient times the standard deviation of y over the standard deviation of x. We will almost always use technology, whether it's your graphing calculator or they might even provide the information here for you. So this is an example of a software program that we won't be using, and on the AP exam you won't have to use it, but they'll give you a picture. And we'll explore this. So as we look at it, our dependent variable, independent variable, response, explanatory, fat gain equals, so fat gain, we're saying our y hat equals, well, here's our A, which is our intercept. Then here's our B, and in this case, it happens to be our slope, which is just from right here. Here's another one. This one's called Minitab. This is a pretty common software program. Fat gain equals 3.51 minus 0.00344. Coefficient, we know what coefficient means. Constant, well, the constant is your y-intercept. NEA, non-exercise activity, coefficient for that's our slope.